Hi, everyone. Welcome to the Physical Database Design session. The previous sessions covered the user requirements analysis, conceptual ER modeling, and logical database design. This session will discuss physical database design. The input to this phase is the logical data model that is mapped from a conceptual ER model. The logical data model is then converted to the detailed definitions of tables. The table definitions are then converted to SQL create table statements to be executed to create those tables in a database system like Oracle. Those SQL statements are usually called database schema. The next phase will carefully select sample data to test the design database to discover and correct database design errors, which will be covered in the next session. Learning objectives. In this session, we will discuss the necessary preparations for the physical design, which include refine primary key design and adaptation of a naming convention for table names and field names. Describe how to determine the data type of each field. Discuss the concept of data integrity and actions to take to assure data integrity. Introduce SQL Data Definition Language, DDL for short, to create database tables, and discuss SQL Data Manipulation Language, DML, to modify data in a database. Discussion roadmap. The diagram shows the sequence of the discussions of those 5 physical database design tasks in this session. The first task is to make necessary changes in the logical data model before starting the physical design. If we followed the conceptual ER model mapping rules discussed in the last session and adapted the recommended naming conventions, the logical data model should be ready for the physical design. That is, each entity in the logical model should correspond to a table, i.e., relation, in the database. That is, the number of entities is the number of tables in the database. For example, the student entity and the advisor entity can be directly converted to 2 tables as shown in this slide. If the conceptual ER model is mapped correctly, all tables should already be in third normal form or higher. Hence, relation normalization is not needed, but it is a very good tool to check and discover mapping errors. It is because a mapping error could result in non-normalized tables. The university database design example for this class showed how to use relation normalization to verify that all tables are in third normal form. The next preparation is to replace all composite primary keys with surrogate keys for easy maintenance. For example, if a primary key is composed of 2 fields, then all foreign keys would be composite foreign keys because a foreign key is a copy of the primary key. Hence, all primary keys should be singular and numeric. If you prefer a string primary key, you should use a short and fixed-length string key to improve the data access performance and for easy maintenance. After those last-minute preparations, we can start to decide the data type for each field. The S requirement analysis should already describe the data type of each field. If the data type descriptions were missed from the user requirements, you should discuss the missed information with the user. In your project, you need to draw your life experience for any missing information about the data fields. The American National Standards Institute, ANSI for short, has defined SQL data type standards. You should reference the Wikipedia link to read the standard. However, the implementation of ANSI standard varies from database vendors. On the other hand, a database vendor, like Oracle, may support other data types. Hence, you need to reference the SQL manual and documentations of the database vendor of your choice to find out the supported data types. After understanding the supported data types, we can then decide the most appropriate data type for each field based on the user requirements. The table shows an example of defining the data type for each field of the student relation. We adapted the tabular format as shown in this slide to define the structure of a table in the database. We have used the terms relation and table exchangeable in the class. To avoid confusion and be consistent, we will use the term relation explicitly referred to relations in a relational database like Oracle. The term table refers to the tabular format used to define the structure of a relation in this physical design session. The first column in the table listed the fields of the relation, the second column showed the data types specified in the user requirements, and the third column showed the data types supported by Oracle that can match the data types in the user requirements. This table defines the structure of the relation and is referred to as relation structure table in this class. After the data type for each field is decided, we can convert the table into a SQL create table statement. Note that comma is the required separator between field definitions. The last field definition should not have a comma. Otherwise, it would cause a syntax error. Should always end a SQL statement with a semicolon. We usually save multiple SQL statements in a script file. The habit of using a semicolon to end each SQL statement can reduce syntax errors. You should interact with ChatGPT to understand ANSI SQL data types, Oracle support, and examples. Example prompts. I am studying the physical database design in my college class. Could you explain the differences between chart and varchart and show me some examples? Could you please explain what ANSI SQL data types are supported by the Oracle database and what are not supported?